Yes, good afternoon. My name is Engineer Shehu Isa Adebisi. I'm going to be teaching you the design of a warehouse, steel warehouse actually, and I'll be using BS Code for the design. So for steel is actually BS 5950, but we're using BS Code. So this my YouTube channel is actually going to be design of steel structures and reinforced concrete structures, and is actually going to be I'll be using two softwares. I'll be using Start Pro and I'll also be using Brutal Structure. But for this one I'll be using Brutal Structure to design the warehouse. Um I'm gonna take you on the principles of design of warehouse, the things you need to know, and we what and this training is actually going to cover the connection designs also. Yes, we'll be doing the connection designs also. So it might be either the part two or the part three, but let's start. As time goes on, then we can be able to do this. Then now, let's start with the architectural drawing. So this is the architectural drawing that was sent. So you can see that we have a warehouse of 56 meters by 56 meters by 36 meters, and you can see that the this is the transverse part, that's the shorter side, and why this is the longitudinal side, that's the longer side. And you can see that this was actually sent by the architect to positions of the stanchions. That is the way where he wants those stanchions to be positioned, which when I checked it, I saw that it actually made a whole lot of sense. So now let's go to the elevation so we can look at the elevation. If you look at the elevation, you see that the total height of the warehouse is 9 meters. The height of the column pedestal is 1 meters. The outer side, the height is 4 meters, while the upper side to the roof, the height is also 4 meters, giving us a total of 9 meters. 9 meters. Then the slope, you see that what the architect is telling us that for that if you that for every 10 meters the slope is 1 meter. That's what the architect is trying to tell us. So the slope percentage, yeah, and if the architect does not give you the slope, the details of the slope that he wants, you as a structural engineer should be able to do that on your own. But what he's trying to tell us is that for every 10 meters the slope is 1 meters. Now let's go into the design proper, and let's start. Now the software that we are going to be using, like I said, is actually Portal Structure, and I'll be using Portal Structure 2021. Now the first thing first is that let us try and look at still it's not like this the reinforced concrete. It's not like reinforced concrete, but now let's look at what we have here. Like I told you, the column pedestal, the outer one, and the uppermost one. So what we have is actually we have three layers. I don't want to call it three floors because you will say that it's not separated by slab, but it's actually three layers. So you see that the total height of the stanchion is 9 meters. Now this is one, this is two, and this is three. Now what we need to do now is this. The first the first thing you do is that you need to insert your story, and based on what we have now, we have three stories. So we click on OK. Now we need to now edit our story. So we go to edit story. You see that I'm coming. I don't know why this thing is not coming up, but from what I showed you, the first layer is that of the column pedestal, which is 1 meter. So this is 1000 millimeter. The second layer is that of the outer bay. That one is 4 meters. that is 4,000 millimeter, while the last layer is also 4,000 millimeter. It's also 4,000, so giving us a total of 9 meters. So we click on what? We click on OK. Now, let me show you what I just did now. This is what we have here. Can you see the first floor, the second floor, and the last floor? So we have a total of what? 9 meters. Now, let's go to the modeling proper. Now, because the orthogonal axis generator is going to be advised. Why? Because we have values that are uniform. We have 5,000, 5,000, 5,000. We have 8,000. We also have 6,000, 6,000, 6,000. So now, let's use the orthogonal axis generator. Now let's go to the so let's model it. You click on orthogonal axis generator. You click on anywhere. Now the direction 1, I'm coming. Let me show you something. The direction 1 is the 6,000, 6,000, 6,000. That is the vertical side. Can you see the way my mouse is coming? The vertical side is the direction 1, while the horizontal side is the direction 2. So what we need to do now is this, is that for the direction 1, which is the vertical side, is actually 6,000 into 6 places. 6,000 into 6 places. So direction 1, you have 6. You have 6. So you have 6,000 then into 3, right? Into 6. Are we together? Then the direction 2, which is the horizontal side, you have 8,000, then comma 5,000 into 8, then comma 8,000. Then you click on what? You click on OK to generate your axis. So this is what we have here. So let's see what we have here. This is what we have. You can see we have 1, 2, 3, 4. Okay, sorry. Okay, let me remove this. It was on 3. I'm coming. Let's do Control Z. Let's do Control Z. So this is what I meant. Click on orthogonal axis generation. Direction 1 is 6,000, 6 meters into 6 places. Why the direction 2 is what? Direction 2 is what? We have 8,000 first, then comma 5,000 into 8, then into 8,000, then 5,000 into 8 rather, 5,000 into 8, then comma 8,000. Then you click on OK. Yes, very good. So you have this now. You have this. Now let us try and the first thing you do when you're doing the structural drawing is try and work on the axis. Make sure that your axis on your architectural drawing coincides with what you have on the structural drawing. Now let's look at the longitudinal side. You see it is 1, 2, 3, 4, 5, but you see that when it got to 7, the architect named it as 9. So you have, instead of 7, 8, 9, 10, you have 7, 9, 11. So we're also going to do the same thing, because the structural drawing and the architectural drawing are going to be used in conjunction with each other. So the axis has to correlate. Now, what I'm going to do now is this. I'm going to change it, because if I change it to 9, it won't work because I have a 9. So let me change this to 8A first. I'll come back and change it back. So this is what I do. 9A, you have 10, you have 10, you have 10A. So okay, this one is 12 actually. This one is 12. You have 12 here. So you click on what? Update. Now let's now change it. Now remember that after 7 you have 9. You have 9. Click on update. Then you have 10. Click on update. Then you have what? 11. You have 11. You click on update. So update, and let's close it. Now we have our axis sorted out. Now let's look at the axis for the horizontals. You have A to G. Now let's look at our architectural drawing. We also have axis from what? A, B, C to G. Very good. Very good. Now this is what I want us to do now. Now the first thing is what? Let's look at our architectural drawing. If you look at this, we have, now let's go to the ground floor layout. Now we are going to position our columns exactly where they are on the architectural drawing. If you have any question, you can drop any question for me on the comment section. I'll reply, and I'll also drop my WhatsApp number. You can send me a message privately on WhatsApp. Now let's place a column pedestal. For the column pedestal, I'll be using a column pedestal of 500 by 500 because I'm actually proposing a section of 203 or 256. But now what I do is that my section plus either 200 or 300, that would actually give me my column pedestal, because you know the stanchion has to sit on the base plate, and the base plate also has to flush with the column pedestal. So I'll be going for a column pedestal of, because I don't want my base plate to come outside. So let's click on column here now. I'll be going for a column pedestal of 500 by 500. Now when you check the architectural drawing, you'll see that we have stanchions in this place. We have stanchions here. We also have stanchions here. Are we together? We have stanchions here. We have stanchions here. And we also have stanchions here also. Now, very good. Now, let's look at where we also have stanchion again. So we have stanchions in we have in green line 6. So anywhere you have a stanchion, there must be a column pedestal there. The load of the stanchion is being transferred to the column pedestal, then the column pedestal transfers the load down to the foundation. Okay. I thought I changed it to 500 by 500. Okay, no problem. I will make the adjustment later, but the subsequent ones will change it to 500 by 500. Don't worry, I'll show you how to change it now. Now, where else do we also have this thing? Do we also have stanchion? So we have, for here we have in line 3, 5, 7, 10. So okay, let's go to our software. So you have for 3, 5, 7, 10. I think we have 3, 5, 7. We have 3, 5, 7, 10, 11. Okay, yes, very good. So we have for this 3, 5, 7, 10, 11. Very good. So I believe we also have at the opposite side also. Let's see what we have here. We also have 3, 5, 3, 5, 7, 10, 11. Very good. So we have also, so just put it opposite where we put it at the top. 5, we have 7, we have 10, 11. So now let me change it let me make everything uniform. So you just click on this, then you hold down your shift key, you click on this, right click, you go to properties, then you click on the section you want to adjust, click on column wise edit, put the 500 there, click on OK, and voila, everything is 500. You can see everything is 500. Now let's go to the 3D and let's look at what we have. Now let's click on the 3D. Can you see what we have here? So this is what we have. Now let's continue our model. Now the next thing is to place our stanchions. Now let me show you something. You see that we have two stanchions of different levels. We have a stanchion that is stopping at 4 meters. Let's go to the section, or the elevation rather. You have a stanchion here that is outside, that is at the 4 meter. You also have another stanchion here that is outside at the 4 meter. Then you now have all the ones that are inside are actually having a height of is having a height of 8 meters. So let me do the ones that are inside first. Now, for the ones that are inside first, we'll go to the we'll go to the let's go to the third floor. Let's go to the third floor. So okay, yes, we are on the third floor now. We are on the third floor now. Now, we need to model our stanchion. Now, if you want to model your stanchion, you go to steel members. You click on column. Now, like I said, I'll be using the uses section, and what I'm proposing is actually 254, 254, 73. Peradventure, I run my analysis and the section fails, then I can increase the section. So let's click on select. Okay, you see that it has changed to 254 by 254 by 73. Now, let me show you this, because you this let's click here. Let's put it here. Now, it's on the top floor, so it's not on the sorry. No. Hey, sorry. The model was supposed to be done. The column pedestal was done on the third floor. Sorry, that's a mistake. It's supposed to be on story 1. That's where the column pedestal is. I meant to go and put it on the third floor. So what we are going to do, let me pause this video and do the correction. Then we can. Yeah, so sorry about that. Let's continue. Now, you see that the column pedestal they are on story 1 now, which is actually 1 meter high. Like I said I want to show you how to insert the stanchions in the middle, which is actually 8 meters tall from this section. You see that all these ones is actually 8 meters, 8 meters, 8 meters, 8 meters, and is actually sitting on the column pedestal. Now, what we have here is this. Now let's go to let me show you. Now, if you want to do this, you click on modeling, go to steel member, you click on column. Like I said, the section I'm proposing is actually a 254 by 254 by 73. It's there already. So you select, you select, then you also click on OK. You select, you click on OK. I'm coming, let me see if this thing is recording. Okay, very good. Select and you click on OK. Now, let me show you. Now, if you place this here, you see that it is suspended. I see that it's suspended. Now, it's suspended because it is a short column here, not a slender column. So now I need to make it a slender column. That is, I need to make it be something like this. Now, how do we do that? I'll show you how we go about it. Now, what you do is this: you click on this, then you click on properties. When you click on properties, then you come to this place that we have length story. Then you click on, then you make it 2 because you want to send it down to the next floor. You make it 2, then you click on update. Can you see now? Now, I want to explain something to you. When you're doing a steel structure, especially a portal frame, as we are doing for this warehouse design, the flange of your rafter should be connected to the flange of your stanchion. I repeat again, the flange of your rafter should be connected to the flange of your stanchion. The rafter transfers this thing, moment and shear, which is axial load, to the column, and it is to be connected to the flange of the stanchion. Now, because of what I just said now, that the flange of the rafter should be connected to the flange of the stanchion. I'm going to rotate this now. I'm going to, because this is the way my stanchion is. My stanchion is actually coming in this direction and in this direction. As time goes on, you see. Now, what we'll do now is this: you click on this, right click, go to properties, and you rotate it to 90 degree. So now it is 90 degrees now. So now we actually have the stanchion the way we want it to be. That is, we want it to be connected to the flange of the rafter, because this is the major axis of the stanchion. So it has to be connected to the major axis of the rafter also. Now, this is what we have now. Now, let's now start inserting our stanchions on the column pedestal. You click on it, right click, go to properties, then just to remember that the one for the outside one is having a smaller height of column. It's having a smaller height of column. So now let's go. You click on this, right click, go to properties. You can snap. If you like, you can use this method. If you like, you can use this method. I actually like this method, but if you like, you can use this method. Okay, sorry. The one outside is a smaller one. So let's right click. Now click on this, right click. So you can snap it. So immediately you snap it, it drops on it. You see, you can do this. You can do, sorry, I didn't click on where I'm supposed to click on. You can do this. So let me delete this. You can see that it's actually coming up. See, it's actually coming up. Can you see? Then we also have here. We have here too. Or you can do it like this. Can you see? Anyone any one of your choice is perfectly okay. Any one of your choice is actually perfectly okay. Are we together? So snap this, do this now. Okay, now I'm going to explain something to you here, but let's still place this also. Let's place this. 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 Let's place this here also. Let's place this. Very good. So now we are through with the stanchions on the third floor, on the last floor, which are slender column. Now let's now place the one on the second floor now. So go to the second level. We are presently on the second level. Let me show you what I'm talking about. This is what I'm talking about. This stanchion here. You see that it is actually at the 4 meter mark. Now we are at the 4 meter mark now. Let's place this now. So you can take this properties and you can place it here. But you see that it is not supposed to be as tall as this one. So what we are going to do is that you click on properties, you go to the length, then take it back to 1, then you update. So it's back to it. Click on it now. You see that it is the way it's supposed to be. Very good. Now we have this now. You click on properties, then you can draw this place here. Can you see? You can draw this and place here. Can you see? Now any form, or you can just decide to snap it. Now this one also, we have the same thing here. You can draw this and place it here. Yes. Very good. Now I believe that this is very okay. Now the next thing we need to do now is to place our rafters, which is to place our rafters. That is, the rafters are actually going to be connected to the stanchion. That's the next thing. I like for the warehouse, I like doing my work on the last level first, then I bring it down. Now, we want to place our rafters now. So For the rafter, you also the same thing also for the rafter, the same thing also for the rafter. So you click on you go to model, then you also go to steel member, you click on beam. Now for the rafter, for my initial sizing, I want to use a member of I'll be using a UB section for my rafter, and I want to use this thing. I want to use this thing 305 by 165 by 40. That is for the initial sizing of the rafter. Or we can even use 356 127 33. It's okay. Or 356 127 39. So let's use 356. It's just an initial sizing. If it fails, then we can increase the section also. So click on OK, and we click on OK, then click on update. Now let's go. Now let's start with this one. Let's start with this one here. So you click on this, you drop it at the middle, drop it at the midpoint. Okay, sorry, we are not at the third floor yet. Yes, okay, we are at the third floor now. We are presently at the third floor now. So let's go. You click on steel member, beam, using a UB section. Okay, very good, it's there. Okay, so start with this. Click yes, drop it. No. Say no. Okay. Let me show you something. Yeah, now let's go to the architectural drawing. Let's go to the architectural drawing. Now, remember what I told you, that what the architect is showing here for the slope, that for every 1 meter, the slope for every 10 meter, the slope is 1 meter. That is what you're seeing here. Now, let's now work on the slope now on the rafter based on that. So you click on this, right click, go to properties, then you go to the 3D. You go to the 3D. Now, we want to take it up. So we come to here, then we'll make it 800 and we'll click on update. Can you see? So what we have just done is that we have just worked on the slope. We have taken it up by 800. That's the height of the rafter is actually projecting up by 800. Now you click on this now, properties, then you take it and you drop it at the middle. Drop it at the middle. Click on escape. Then you take this also, drop it at the middle. Click on escape. Take this, drop it at the middle. Click on escape. Take this, drop it at the middle. Click on escape. Take this, drop it at the middle. Click on escape. Take this, drop it at the middle. No, then you also click on escape. Now, very good. Can you see? Now let's go to the next one also. I want us to do this first, then before we now do the other side. Now, come here, take it, drop it at the middle. No, click on escape. Take it, drop it at the middle. Click on escape. Then take this, drop it at the middle. Click on escape. Take this, drop it at the middle. Click on escape. Take this, drop this at the middle. Click on escape. Take this, drop it at the middle. Click on escape. Then take this, drop this at the middle, and you also click on escape. Now let's do the other side now. Let's come here, you click on properties, go to 3D, make this 0, then we'll make this 800. You make this. If you have any question, please just ask your question on the comment section. Say no. Can you see? Take this, drop this at the middle. 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 Take this and drop this at the middle. So say no. Are we together, please? Hope you get what I'm saying now. Let's come to this place also. Take this, drop this at the middle. Say no. Take this, drop this at the middle. Take this, drop this at the middle. Take this, drop this at the middle. Take this, drop this at the middle, take this, drop this at the middle, take this, drop this at the middle. Say no. Very good. Now you can see that our structure is coming up. Now let's do for this side now. Let's do for this one. If you look at the architectural drawing, you see that let's do for this one. It's also the same slope, but the span of this one is 8 meters. That means the height of the rafter here is going to be 800. Now this is what we have here. Now let's go to the second floor. Pick this, click on properties. Let's make this okay, sorry. Sorry. Let's go to the third floor now. Let's go to the third floor. Now let's go to the beams. Click on this, right click, go to the last one, properties. Is actually supposed to be 1 meters, 1 meter, not 800. So you click on this, is 1 meters, is 1000, not 800. So you close it. Sorry, the slope is supposed to be 1000, not 800. Okay, let me pause the video, then I'll quickly. Okay, so the correction has been done. Let's continue now. We want to do for this one now the outer bay, those sides, the outer bay. Now because its own is 8 meters, so the slope is going to be 800. Why for this one that is 10 meters, the slope is 1 meter. I've already made the corrections to 1 meter. You see now. Let me show you just one. Then properties, and let's go to 3D. You see that it's now 1 meter now. So let's close this. Now let's go to the second floor. Let's go to second floor now. So let's click on this. Properties, go to 3D to make this 800. Make this 800. So bring this here. We'll bring this here. We'll click. Can you see? Bring this here. You click. So you can see that the structure is coming out now. It's coming out, and it's coming out very, very. Sorry, this is one. So let's click on this so that the structure is coming out very nice now. It's coming out very, very nice now. Structure is coming out very, very nice now. Click this. So now let's come here. Click this also. Now very good. Now let's come to the other side. For the other side, we'll be making use of this. Now, so for this one, we'll click like this. For here, we'll click this. For here, put it here. Please, if you have any question as regards what I'm doing, you can I'll drop my WhatsApp number for you, so you can ask any question. So let's click on properties. We'll drop this here. Let's click on properties. We'll drop this here. Then we'll drop this here. Very good. Now you see that the shape of the warehouse is actually coming out now. Okay, so yes, I said I was going to explain something to you as regards the stanchions on the perimeter here. That are the perimeter. Now, for the stanchions that are on the perimeter here, these ones here that are going to be holding the steel section, the orientation is actually going to be different. It is actually going to be different from the ones that are being connected. This one is actually like a support. It's actually like a support to it. So its own orientation is actually going to be different from the ones that we have actually placed before. And I'm going to show you how we are going to change the orientation, and how we are going to make the stanchion to go up and meet the rafter. Now, so for this now, let me show you for this. So for this now, go to properties. let's rotate it to 0. We update. So you see that the orientation has changed. Orientation has changed. Now, for us to take it up now, for us to take it up to the rafter. Now remember that this one is the from this place up is actually 1 meter. So the stanchion is already at 1 meter. Now you see that this one is like half of the 1 meter. So for me to take it up to flush with this, it is actually going to be 500. Go to properties and go to 3D. We'll go to 3D. Then for top, because I want it to go up, so I'll make it 500. Then we'll click on update. Can you see it now? Can you see it now? Now let me click on this. Now let me click on this, and let me also click on this. So click on properties. For the top is 500. Click on OK. Then for the angle is, remember that those ones are actually outside. They are not the connection type. They are just meant to just hold it in place like a support. So OK. Then let's see. Let us see. Let's see. Yes, very good. Now let me do for this ones. For this bay too. Let me do for this bay too. So let's click on properties. So yes, this is 0. Okay, then we go to the top. The top is 500 to take it up to flush with that. So very good. So we are done with the modeling of the stanchion now. Like I said, if I'm actually designing a warehouse, I like designing from top to bottom. Now you see that we've actually worked on the stanchions to the top, and we've also worked on the stanchions to the 4 meter place. Now let's go to the column pedestal. Let's go to the column pedestal. Yes, let's go back to the plan view. Now, if you look at the architectural drawing, you see that we have a column, we have tie beams, we have these are partitions, by the way. These are all partitions. Now, if you look at architectural drawing, these are all partitions. But what the architect is saying is that the partition is actually at a height of 4 meters, while the remaining ones is actually going to be covered with a cladding. So now for anywhere you have partitions in the warehouse, we are going to introduce a tie beam in which the block is going to sit down. Now let us introduce our tie beam now. Now let's go back to our software. Now let's go to our beams. This is our beam. So we'll go to modeling. We'll click on beam. Yes, I'll be using a beam of 230 by 450. If I run the analysis and maybe anyone feels due to span or anything, I can always come back and increase. Now this is what we have now. This is what we have now. This is what we have. So I'm also bringing this here. I'm bringing this here. So I'm actually connecting this. I'm connecting this. I'm also connecting this. I'm also connecting this. I'm also connecting this. And I'm also connecting this. Very good now. So we have all our tie beams in place now. We have all our tie beams in place. I'm coming. Let me show you the architectural drawing. So let's go to the foundation layout. You see that what we have here is actually a replica of the model here. And let me show you what we have on the 3D. Can you see? Can you see the tie beams? Can you see that all the tie beams are actually in place? They are in place. Now, you see that in the architectural drawing, we actually have we have partition allowances here. and the partition is actually 4 meters high. 4 meters high. Can you see? So let us go and add our partitions now. Let's go and add our partitions to it now. Now, let's go back to the plan view. Let's go back to the plan view. Now, for the partition, let's pick one. Let's pick one of the beam. Then you go to edit load. Yes, he said we should do our load this thing. So for this now, you click on load generator. When you click on load generator, we want it to create factored load for steel and concrete. Then the horizontal load combination will be applying a wind load. It's a steel structure is actually going to be, it's actually going to be subjected to effect of this lateral loads, even if it's actually 9 meters high, but we'll be applying a wind load on this structure. So we have everything, and we also have our wind load check. So you click on OK. So this is our load combination. Because we are using BS code, that's why you're having 1.4 by 1.6. So we also have OK now. So the wall load command is actually going to come up now. Let's wait for it. Yes, it's here. The wall load command is here. The wall load command is here. The wall load command is here. Now, I'm going to be explaining something to you. And what I want to explain to you is that for the wall load, the unit weight of a block is 2.87. 2.87. That is the unit weight of a block. So ordinarily I'm supposed to put 2.87 here. 2.87 here because that is the wall unit weight. But if we put 2.87 here, that means that we are not actually taking the plastering. It is the 2.87 is minus the plastering. That means that we are not taking the plastering into consideration. So now the plastering, you have to plaster inside and outside. Now when you add for the inside, the unit weight of the plaster is actually 30 millimeter. 30 millimeter. Now when you add 30, that's 60. That's 60. So when you add it to 2.87, you will now be having 3.47. That is why we actually make use of 3.47 here. Now on the architectural drawing, you see that the height of the block is actually 4 meters. So we make this one 4,000 meters. And because we are in Nigeria, the unit weight of our block is 230. Is 230. So we make this 230. Then when you do that, you will now come and click on this for it to be 3.47. Okay, you click on update. So let me cancel this and do it again. Let me cancel this and do it again. We'll go to edit load. Wall load is there. So you click on update, then you click on this, then you click on OK. So this is what we have now. Now, if you hover your mouse on it, you have 3.47 4 meter. The 4 meter is actually gotten from the architectural drawing. You can see what the architect is saying is that we'll be having a block work of height of 4 meters. Then we will now be having a cladding of 4 meters that's actually going to cover the perimeter this thing. So let's just continue. Now, since we have done that, then you now come here, you click on this, you click on copy load, click on OK. Then since all the beams are having the partitions, you click on the first one, hold down your shift key, then you click on paste wall load. Now everything has been pasted. Now let's go to the 3D and let's see what we have done. Can you see now? Can you see that everything is coming up now? Can you see that where we're supposed to have partitions, we have our partitions. Where we're supposed to have our partitions, we have our partitions. Everything is in place now. Now, the next thing that we are going to do now is actually to model our pole lines. is to what? Is to model our polines. Then after the polines, then we can start talking about the yeah. So like I said, the next the next step now is to actually model the poline. And how do we go about that? To model the poline, you come to steel members. You come to steel members, then you click on poline. Once you click on poline, then you click on, oh sorry, let's put the bracing first. Let's put the bracing first. So the way I brace my structure is that I brace my structure. um you can't brace all the structures at once, so you just put it at strategic places. So me, I brace them in such a way that I brace one B, I brace one panel rather, I leave the next panel. I brace one, I leave the next panel. So let's put our bracing. If if you want to brace, so you click on bracing, then you click on the rafters, click on the rafters. It brings out this dialog box. Now because the span is actually much, because it's actually 10 meters, so from experience the section is actually an equal angle. So from experience I would actually prefer I use a bigger section of the equal angle. So I'll be using 150 by 10 for my bracing. So I'll click on this, I'll press OK, then I'll also press OK. Voila, it's here. Then I'll leave this panel, I'll come to the next one, I click on this, it comes out, I click on OK, leave the next panel, I click on this, then I click on OK. Are we together? Then the next one, the one here, I click on OK, click on this, I click on this, I click on OK, then I click on this, I click on this, I click on OK. Very good. Now let's come to the other side. I click on this, I click on this, I click on OK. I click on this, I click on this, I click on OK. I click on this, I click on this, I click on OK. I click on this, I click on this, I click on OK. Click on this, I click on this, I click on OK. I click on this, I click on this, I click on OK. Yes, so the rafters has been braced. Now let's go to the stanchions. Now, because when you look at the architectural drawing, let me go to the plan. So I can brace the shorter side, the two shorter side. I can brace it and leave the longer side, maybe for entrance. But what the architect is saying here is that both the front and the back. Let's look at the elevation. What the architect is saying here is that both the front and the back, are all gonna be braced, and they are all gonna be braced. Both the front and the back are actually having partitions. So now let's now put bracing also. I will leave the longer side, I won't brace it. So for that one, I'll be using a moment connection to resist the forces. But for this one that we don't have any doors and that is actually not hindering anything, I'll be bracing it. Now let me show you um how 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 we are going to go about that. Then we'll come to this one. I click on this, I click on this, I click on OK. Hope you understand what I'm doing. I click on this, I click on this, I click on OK. I'm coming. Let me see. I hope I hope you can hear what I'm saying. I'm coming. Let me see. Just to let me put it in 100. Yes. Then yes. I click on this. I click on this. I click on OK. And let's come to this one also. Let's come here. So I click on this. I click on this. I click on OK. That's the rule for I click on this. I click on this. I click on OK. Yes. I click on this. I click on this. I click on OK. Now let's come to the extension. I click on this. I click on this. I click on OK. I click on this. I click on this. I click on OK. Oh, sorry. I click on this. I click on this. I click on OK. And I pressed delete. Now let's come to this place. So let me put my place. I click on this. I click on this. Okay. Then we'll come here. Come to still member. We'll click on brace. So I click on this. I click on this. I click on OK. I click on this. I click on this. I click on OK. I click on this. I click on this. I click. Okay, sorry about that. I click on this. I click on this. I click on OK. I click on this. I click on this. I click on OK. Then I click on this. I click on this. I click on OK. Or let me just quickly. Okay, I'm almost done. I click on this. I click on this. I click on OK. I where are we? Let me press escape. Let me go still member brace. I click on this. I click on this. I click on OK. Okay, can put let's put here too. I click on OK. I click on this. I click on this. Very good. So you can see that the structure is actually coming up now. It's coming up now. We have our brace in place. Our brace in place. Now let's put our pole lines now. If you want to put your pole lines, come to steel member. When you come to steel member, then you click on pole line. When you click on pole line, then you click the first one, then you come to the last one, you click, then now let me pick the section I want to use. I actually want to make use of the Z pole line. If you want to make use of the Z pole line, where you go to is that you go to Malaysia. Once you come to Malaysia, for the Z pole line, this is what we have. We have 20 by 20 by 3 for it. Okay, this is Z pole line. Let me pick this. Let me pick this section 150 by 16 by 2. Click on this. Click on OK. Then the other things are in place. The sag rod, okay, but the spacing should be 1.2 meters. 1.2 meters. When you see, let me take it back to 1000. Let's leave it at 1.2 meters. Now, very good. It's actually coming out now. Now let's go to the sag rod. Let's go to the sag rod. Let's go to the sag rod. We have everything in place. We have everything in place for the pole line. So let's click on OK. It has come out. Now let's put the pole line for the other ones. Let me pause the video and put or let me show you for this one again. You pick this. You pick this. Then you click OK. Can you see that it's coming up? You pick this. You pick this. You click OK. I see that it's coming up. Pick this. Pick this. You click OK. Can you see that it's coming up? So now the next thing is for us to put, this place is covered, so we need to put a grid here, not necessarily a pole line, because it's actually covered with the cladding. So we'll go to steel member, then we'll click on grid, you click this, click this. Now if you, the spacing should be 1.2, please. 1.2. So you have the sag rod. These are the sag rod. So let's click on OK. Let's click on OK. You have this. So you can see that the grid is going beyond where it's actually supposed to be. It's actually supposed to be up here. If it's actually supposed to be up, it's not actually getting down. So what we'll do is that let's come to the grid. Let's click on properties. Then we go to offset. Now bottom member offset, because from the bottom to where it is exactly 4 meters. So click on 4 meter. You can see that it's actually, you see that it has been adjusted now. Very good. So our design is actually coming up. Then let's go to the other side also. Let's go to the other side also and put our grid. Let's come here. Yes. It's okay. The section is okay. So click on OK. Yes, it's actually making a whole lot of sense now. It's actually coming up now. Now we are through with our pole lines and our grids. The next thing to do now is to put what? The next thing to do now is to put our cladding. Let's put our cladding now. The cladding is the let's put aluminum sheet now. For the aluminum sheet, to put the aluminum sheet, come to steel member, click on cladding. For the cladding, what you need to do is actually just, I'll show you what I'm talking about. So you click on this, you wait for it to come out. So it is out now. Once it is out, then you click on OK. You wait for it. Now the cladding is in place. You click on this also. You click on OK. The cladding is in place. You click on this also. Click on OK. Cladding is in place. You click on this. Click on OK. Cladding is in place. Okay, sorry, we haven't put the pole line on this one. Now let's put our pole line on this one now. So go to steel member, click on pole line, pick the first one, pick the last one, click on OK. Are we there? Go to pole line, pick the first one, Sorry, let's cancel it. Pick the first one, pick the last one. Okay, now yes, voila, we have this now. Now let's put our cladding. Let's click on this. Let's go to properties. Steel members, where is it? Modeling, steel member, cladding. Click, say okay. Then come here to click, say okay. Now, very good. Structure is actually coming up. It's actually coming up now. I would appreciate if you have any questions that you would like. That is, if you don't understand, I can drop my personal number for you, so you could actually reach out to me privately to try and explain to you, or you can drop your questions in the comment section of the video. Now, this is what we have now for the steel section. Now, the next thing we are going to do now is to put the loads. Is for us to actually put the loads. Now, the load, I mean, now the cladding is only actually going to be affected by the self weight and the life load of the roof, which is actually according to the 663 now, which is actually between 0.5 and 0.75. So now let us load now. To load now, I'll show you how we load. So okay, we have to put a cladding here too. So let's come here. Let's go to modeling, steel member, click on cladding, click on this, click on OK. Then you also come here, click on this, click on OK. Very good. Now our structure is coming up now. Can you see? It's coming up, it's coming up. So now let's go to let's go to let's go to Google and just say the self weight of the self weight of an the self weight of an aluminum roofing sheet. I have a lot to teach you guys on this channel. Like I said, I will be teaching you guys on Start Pro, how to use Start Pro, and I'll also be teaching you guys on how to use how to design both this reinforced concrete and steel. We'll be using both Proto Structure. I will also be using Start Pro. Now, let me show you how to load the structure. Now, load the cladding. Now, let's come to the cladding now. Let's click on this. Let's start from the first one. Now, let's start from the first one. Let's click on this. Then you go to edit load. Once you go to edit load, you see that a dialog box like this is actually going to come up. This is going up. Then we are going to highlight. We'll have to highlight this. Since it has been highlighted, then we'll go to full uniform area load. The full uniform area load. Click on the full uniform area load to load. Now, of course, your G is your dead. Your G is your dead load, while your Q is your life load. So now it's actually going to put the dead load. It's actually not now to put the dead load. So we are going to we will need to put dead load. Now let me show you what I wanted to do the other time, in the sense that the dead load is only the self weight. Now that's why I was trying to come to Google the other time. I don't know if my network is up. Okay, my network is up. I was trying to come to Google the other time. Now, self weight of aluminium sheet in kilonewton per meter squared. Let's click on OK. Okay, we have one instruct view. Let's go to struct view. Sorry. In order for us not to waste our time, maybe we can just use chat GPT. I use chat GPT. Let's use ChatGPT. This one is saying intense limestone, volcanic limestone. Okay, this one is for timber. This is for timber. Okay, for aluminium, aluminium. Let's use ChatGPT. Let's let's use ChatGPT. Yeah, let's use ChatGPT. We want to get the soft weight soft weight of aluminium sheet in kilonewton per meter square. Just to make it fast, self weight of aluminum roofing sheet. Just just to make it fast. So let's go. Now, this is what ChatGPT is saying. Now, these are the options that it's bringing out. For the self weight aluminum roofing sheet is typically in the range of 0.0122 to 0.020, depending on the thickness. So now, from what ChatGPT is telling us now, that the for a thickness of 0.70 that the weight is between 0.020. So let's use 0.020. So we'll now come to the software now. Let's come to the software and put point 0.02. Then we'll click on update. Are we there? On 02. Okay, sorry, it's not. Okay, sorry, I know what the problem is. Let's cancel. Okay, so let's come back again. Let's come here, edit load. One uniform weight is 0.02. Then we highlight. So can you see now? You see now? Now see that the load is now acting on it now. Now let's go to the live load. The live load is between 0.5 and 0.75. But let's pick 0.75. 0.75 according to the code. So let's pick 0.75. Click on this. Can you see we have 0.75, right? Then we will now click on OK. Very good. You see that the structure is coming up. Now when you hover on it, it brings out the load on it. Yeah, let's come here too. Let's click on edit load too. So click on full uniform area load. Remember we have 0.02, and let us highlight. Let's see if it's 0.02. Click on, then let's go to the live load. The live load is like I said, 0.75. Click on update, highlight it, and let's see. Then you click on OK. Let me do for the third one, then I'll pause the video and complete for the rest, so we don't take much time on it. This one, you go to edit load, click on this 0.02. Can you see 0.02? Then yes, this is 0.02. Then let's go to the live load queue. Then let's use 0.75. 0.75. Let's update. Then let's highlight it. Very good. Okay. Now let me pause the video and quickly do for the rest. Yeah. So I'm through with the loading of the aluminum based roofing sheet. Now the next thing is to now do our settings now. Now let's go to settings and let's try and do our settings. Then after that, I will end the video. Then the next video will now be the analysis and how to correct any section that failed and what have you. Now let's go to settings now. So now if you want to you come to settings, come to setting centers. When you come to setting centers, then we'll be able to do settings. Now the first one is a column. So we have design, we have this. Let's come to rebars. Let's go to select wall containment. So if there's a need for it to have a double link, let it have a double link. Even if there's a need for it to have a triple link, let it have a triple link. Then we'll come to wall containment, come to longitudinal bars. Now I want the maximum to be 16 and the minimum to be what? 25. Then yeah, he said the concrete cover of 25 will be used when zero is entered, which is okay. Now let's go to the links. The links, I want my links to be 10 mm. I want the minimum links to be 200. This one also, I want it to be 200 also. Then let's go to the beams. Remember, we have some concrete beams. Now, minimum should be 16. Minimum should be 16, then maximum should be 25. Minimum of, so then let's put 10 mm here. Let's put 10 mm here. So what he said is that concrete cover will be calculated according to the code provision if zero is entered in the field. It's okay. The link properties, maximum support link spacing, I want it to be 200. Let's put 200. Maximum span link spacing too, I want it to be 200. Let's put 200. Very good. Now let's go to the slab. Let's go to the slab. Let's go to the slab now. Okay, sorry, I don't have a slab, but I just like setting. I like setting all my properties. I like setting all my parameters. When I'm doing it, is loading. It's loading. So for the slab, my rebars, I want it to be a minimum of 12 mm. 12 mm. Then I want it to be 12 by 12. We don't have a bar. I'm just setting it. Then let's go to the foundation. So the foundation, of course, my soil vertical my malleable soil strength is 200 kilonewton per meter squared. That is what the soil is. I want it to be a square part footing. Then we can check this. Then let's make it minimum of, it won't use, because it doesn't have 12 mm, it won't use 13, it will use 16. It will use 16. Then let's go, then we'll click on okay. So that has been set. Can you see? That has been set. Now let's go to analysis. Let's click on building analysis. Let's go to building analysis. Now let's check our model first. If there are any errors there. Let's check our models. If there are any errors on our model. Let's see. Let's see if we have any errors on our model. Okay, no, we don't have any errors. So now let's go to analysis. No, this is where I want us to come to. Now you see, now all the grade of steel column should be X275. Everything should be X275. Everything should be X275. Although we don't have trusses, but let's just leave it as at S275. Let's leave it as at S275. Yeah, the brace members also S275. Let's leave it at S275. Then where are we again? Okay, we don't have any frame members, but let's just set everything to X275. Then for the concrete, I like it to be C10. Then I want it to be C25. Okay, so everything is C25. I guess we are good to go. We are good to go. Now let's go to the wind load now. Let's go to the wind load. Let me see my load cases. Okay, the wind load. Now let's go to the wind load. Now let's go to analysis. No, let's go to loading. We go to wind and story load. Then we'll go to wind load calculator. Let's go to wind load calculator. Now, because it's Lagos, so the basic average wind speed for Lagos is actually 30. That's the basic actually. The basic wind speed for Lagos is 30. Then we can leave this as the fourth. Can leave the rest as the fourth. We can this category is saying area in which at least 15% of the surface is covered with buildings and the average height exceeds 15 area with regular cover of vegetation or with isolated obstacles with separation of minimum of 20 grass and isolated. So let's go with category 4. Let's go with category 4. So the structure is steel. It's steel, not it's not reinforced concrete. It's steel. It's steel. Structure is steel. So let's leave the rest as let's leave the rest the way it is. Let's leave it the way it is. Yes. Let's leave it as default. Let us leave it as default. Then click on apply. Then we'll click on OK. So the wind load has been applied. Now let me pause this video. Then the next one will now be us running the analysis and seeing if any members failed. That will be the next. So let me pause the video and we will continue from there in the next video. Thank you very much.